Your new company, John, should be Scotch and Logos.
I like that. All right, I'm gonna head off of video, and I'm gonna put up your slides and get going. Thank you. I'd like to introduce Winn Schwartau, who's speaking. AI ain't so smart, eh? Take it away.
Good morning. Good morning for whatever month this is. I just want to make sure, does you see one big screen or lots of little screens? I got so many views here. John, anybody? Hello? Oh, thank you. All right, that's better. Good morning and all that again. Sorry about that. Before I begin, I want to acknowledge a few things. Number one, CornCon and John for gluing this whole thing together so quickly. And I was just telling him that one of the ways that I measure my interest in a conference and its success of it is how many pages of notes I've got. And I've got lots of pages of notes, and that for me is always a big clue. So thank you, John, and the crew there for doing this. It's been really good. Number two, this talk on AI, I want to give some credit to a couple of gentlemen. One is Clarence Chow, a gentleman I met in Paris, and he was talking on AI, and then my brain started thinking because I had been working with another brilliant gentleman who spoke yesterday, Dr. Mark Carney, and we all met in Paris, and Clarence wrote an amazing book. If you're interested in the AI world of AI, it's called ML, Machine Learning and Security. So I want to give him a lot of credit for really inspiring and mentoring me for the last 3 years on and keeping me honest on it. And then with Mark, with the math and all the background stuff, just to make sure that I don't completely screw it up. So just want to make sure this isn't all me. This is a lot of people helping me along in the last few years. And also with regards to Stephen, I absolutely loved your talk, and mine is not quite as existentially depressing, but I get it. But we are going to talk about AI from a slightly different view. Okay, so I know how to do graphics. Cool. I'm going to show you some offensive stuff. So I don't want to hear about it. I don't want John to hear about it. Put in chat, since we don't do raising hands here, that, yeah, you agree that I'm going to say some offensive stuff and you're not going to get pissed off at it or hold anybody accountable, because everything I'm going to show you is going to be real. And then if you don't like it, leave now and then we'll talk later. Cool. These are the items that we're going to kind of run through quickly, because I know I don't have as much time as I would normally have. And for those items I skim over, I'm happy to go over to a side channel here, voice channel, afterwards, and get into some of this stuff a little bit deeper than I'm able to here in these few minutes. When you leave this talk, hopefully you're going to have some questions, and that's really what the goal of this is. I'm not going to give you tons and tons of answers, and you'll see why in a few minutes, that there in many cases just aren't. But the biggest thing, and for the engineering mindsets and hacker mindsets, is questions is always a great route to get where you're trying to go, whether you actually end up with a hard answer or not. In my view of AI, really simple, we got to begin with AI does not give you answers. It is not absolute. It is not a deterministic binary function that's going to go yay, nay, 1, 0, yes, no. It's not. AI is probabilistic. Some people might use fuzzy. I like the word analog, crass commercial plug for my book, because there's some AI stuff in there as well, looking at it from an analog standpoint. So it's a probabilistic issue, and any answer you think you're going to get is going to have some degree of error. And we're going to look at those error reasons, some of the reasons for error, and how the level of trust that you have in the results of AI are important. Now, some vendors are going to get really pissed off as well, because so much of what generated this talk was sitting around RSA meeting 400 vendors all saying, we have AI, we're the best AI, our guys are the best. Well, no, that's just not going to be true. The third thing to keep in mind, absolutely critically important, is that nobody knows how AI comes up with its answers. And I'm using answers in a probabilistic sense here because it's not binary. We don't know. Data scientists don't know. And I'm also going to add one more caveat to this talk, is that all of this stuff that I'm talking about is true to the best of my knowledge and is fairly well documented. If there's new stuff that's happened in the last few weeks that I've missed, please educate me and let me know. One of the issues that's also going to be a big deal is you can't explain AI. And for those that are compliantly oriented, especially with GDPR, there are some interesting wordings in GDPR about explainable AI, and in that fundamentally you can't use AI unless you can explain it. So there's an internal contradiction there, ergo one of the issues of the Kobayashi-Maru concept behind this. Data sets, bias, we're going to get into that. And then after all of this, it's the questions that you need to ask your vendors as to is AI right for you for the particular application? So a fast thing, I live in Nashville, and the cityscape on the left is what an AI interpreted a picture I sent in from the right, and it's kind of interesting what it turns out. Now, my wife and I did this experiment when Deep Thought, I think it was, first became available online. So took a little picture of my wife, and we plugged it into Deep Thought, and 30 seconds later, out came the picture on the left. My wife and I are saying, I wonder what happens if we put the same original picture into the same Deep Thought, into the same algorithm, and see what happens. And we got the picture on the right. As you think about AI, you got to keep in mind that every time you ask an AI a question, it influences its future answers. You very well may not get the same answer, even if you're asking the AI the same question very, very quickly. And this has big influence in the trust factor that we have with these types of systems. Now, before we get really into all of this, I hate the term artificial intelligence. Number one, to Stephen's point earlier, we really don't know what intelligence is. Are we intelligent? Maybe. Can we define it? Nope, not yet. The philosophers have been messing with us for thousands of years. And so when we say AI, that implies that we know what intelligence is, and we've had some way already to imbue it into technology. Simply not true. Not true at all. It's a marketing buzzword that has been stolen from science fiction from 70 years ago and applied because it resonates with public and the memes and all of that. What we're really talking about when people say AI, it's machine learning, it's deep learning, it's neural networks. And to what Mark talked about yesterday, if you'll recall in his quantum talk, he broke it all down that these are, in quantum computing, logic gates, and those are fundamentally implemented. I think he was showing Python, some of the examples there. It's in code. Same thing with neural networks, machine learning, deep learning, anything, and what marketing people call AI. It's software and all of the problems that get associated with it.
Hey, Winn.
Now, yes.
If you thought you were showing slides, you're not showing slides.
Well, that really sucks.
It was a great conversation. I liked what you were saying. I just thought there might be slides to go with it.
Well, there are a whole boatload of slides, and why didn't somebody say something earlier?
I was waiting to get a word in.
Oh, all right.
Just do the
Did
share
mine?
screen.
I know. It looks like my entire window went away. All right, there we go. Yeah.
Okay, I'm seeing, oh, there we go. I see I see your entire screen. Okay, I see the
All right, then I'm
slides
going to
now.
go back just these really quickly so people know that there are actually slides there that they can take, and the slides will be available. Mike, deep apologies. Thank you for reminding me, John. So those are the question we talked about. Those are the bullets you can have. The AI picture of my wife, the one on the left, that was input number 1 to the AI, and a few minutes later, identical input and the very different output. AI, what is it? Is it intelligence? We went through that. Now, here's where we're supposed to be. Thanks again, John. When we talk about AI, and I like to use black box analysis because of the analog network security kind of modeling of input and output. We use it in all phases of science. We may not know what the black box does, but we can measure the input, measure the output, and come to some conclusions. Now, is a human an AI? Is a human a black box? In certain modeling, yes, it is, because you can look at the input, you can look at the output, but can you explain the process in the middle? And this is the same problem that we have with explainable AI, and we're starting to imbue these systems into our technologies and security. Say, okay, we're going to add some AI. Yeah, but the input, the output, and how do I get there becomes exceedingly critical. And yes, sir.
Would you hit that button that says swap displays at the top?
At the top, swap displays at the
Up,
top.
up above the little timer and the slide, there's something that says swap displays. Great, we see it full screen now. Thank you.
Oh boy. And that compresses my screen, and I have no idea. We'll deal with it. We'll deal with it. Now, which button do I use? Okay. So this ultimately becomes the issue of garbage in, garbage out. If we do an input 1, the output is going to look different every time. Now, the garbage in, garbage out issue becomes part of what is bias. For those companies, and I've heard it at RSA too many times, our data is neutral. The answer is no. There is no such thing as neutral data. All data is biased in some way. And we have seen the problems with that. Are more people, women sampled, men sampled, age group, financial, economic condition sampled? How do you define your samples? And when we look at it from a security standpoint, I'll get into how some of these issues make the answers that you come up with maybe very, very wrong. So bias is a key component and of the problems that we have with ML, neural networks, and the whatever it's called, AI these days. And Clarence's book gets into this very interestingly with an awful lot of the detail on what creates bias. Dr. Carney does exactly the same thing by looking at it from a, whether it's a disease standpoint in the biological world or is it code problems, the model is identical, however you're looking at any of these. So this then brings along, if I know that I have a biased data set, which has to be your initial conclusion because there is no other answer, then every time a decision is made, you run into potential ethical questions. And those questions are, which way do I go? Which way does my probabilistic output of my deep learning mechanism, my machine learning systems, which way is it going to tend to go? Well, those are going to have to be programmed in. And those programmed decision makings are, in this case, ethical biases, which is something that has been terribly overlooked in the entire world of AI. So the typical trolley problem here, which one are you going to do? And live audiences, it's a lot of fun going through this and then having people argue about it. But we got to look deeper into it, in that, are we willing to give away certain decision making, life and death decision making, in any of our cybers, or our human cybers, or our kinetic cybers? Are we willing to give away this level of control to a system that we do not know how it works, and we know the initial conditions are biased? So our trust factor at the very beginning is suspect. So another Kobayashi Maru issue here is depending upon programming. And I like going to Asimov's first law of robotics, which says, rule one, a robot shall do no harm to a human, or through inaction, and that's the key word here, allow a human being to come to harm. So if you take those conditions as a rule set and plug it into a decision-making matrix, whether it's ML or binary, what's going to end up happening? You're going to have runaway conditions. You're going to have the switch flipping back and forth in infinite speed, never making a decision, because in this particular case, the ethical decisions are completely at odds with each other. Yet that is the real world that we're expecting a lot of these systems to come up with. How far do we carry the problem? Now, in this case, we've got a very simple binary condition. Do you save the lady? Do you save the gentleman? And do you become part of the process, or do you lack free will and let the universe make the decision for you, which is part of the ethical issue? And Stephen is much better to speak to that than I am, but I'm sure we're going to talk a little bit later. Now, let's get into some of the offensive stuff. Is this going to make a difference? And one could argue, especially in today's climate, oh, hell yeah. And so the bias of the set and the decision-making matrices become increasingly based upon the human sets of biases that are needed in order to program these systems. Does that change the equation? Here's another one. And these are all real-world conditions as we deploy anthro cyber-kinetic systems, those systems that have the human component, the cyber component, and the kinetic component, such as drones, automatic cars, autonomous cars. We are deploying technologies that are making life and death decisions more and more and more. And again, reference back to some of Stephen's issues, and this becomes both a human decision issue and a technical issue. And can an AI ever get into a runaway condition on its own? Skynet-ish kind of things that he was talking about. Various cultures place different values of lives on various types of lives within their systems. How does that affect our ability to make an autonomous system and deploy it globally? The ethics are different. So therefore, does that mean every single system that's autonomous that could have an effect on human lives has to be reprogrammed and rebiased and weighted for that culture? And who makes those decisions? Or is it one universal cultural decision? We don't know these answers, but it shifts when you go around the world. Or do you take a sort of a Kirk-like issue and say, to hell with the problem, I'm gonna go back to the source and fix something much earlier in the process? And so that is part of the Kobayashi Maru that we are facing as we deploy all of these things. So when you're building your bias, when you're building your data sets, who do you trust? Who do you trust to do it? And both of these are very, very different. But Mother Teresa, okay, you may trust the hell out of her, but do you trust the hell out of her for certain decisions, all decisions? Or are you going to give her the quantum physics decision? You're going to give her the math? You're going to give her the technical stuff? Or just, here's how to act ethically, but is her ethics going to be slightly different than those from other religiously based cultures? Is there an answer? I would argue no. So this is not a new problem. It goes back to Babbage, and he's the one who first came up with the effect, the concept of garbage in, garbage out. He knew that. And then today, it is even more so. And we have seen this absolutely happen, and we can make it happen through poisoning, and I'll get into that, of existing AI systems. And I'm using the word AI, and I really hate that I have fallen into it. So ML, smart systems, DL, whatever term is not AI, it changes. All of it changes based upon the input, and the input to a system is a question. So by asking a question, you are going to change the answer that the next person is going to have over a period of time. And bias shifts over time. And I know I've talked about time and security now for 30 years. I'm not going to give up on it. But again, time is absolutely critical to this because bias is going to shift over time. The bias of a neutral network, which does not exist, neutral data, which does not exist, means you are going to have a degree of bias. Now, how do you monitor that bias? That becomes a separate question that groups like Microsoft and Google and those guys are looking into, but it still has to focus back on that zero line. What is neutral? What does neutrality mean in a decision-based, automatic-based system? We don't know. We don't know. And your answer of which way the pendulum swings and is it good or is it bad, that's going to be a very different answer. And we put 10 of us together discussing it, we're going to have 10 different answers. Now, we do know that optimally, we would like to use what's called a damping curve so that the bias swing is minimized over time. It's never going to hit zero. It's never going to be perfect. Absolutely not. We're never all going to agree. And even with a self-reference system, it still will never be perfect. There's always going to be something that's going to influence that bias one way or another in the decision-making process. So this is where we are looking at feedback systems, some of the OODA concepts from analog network security. A lot of these are being discussed now to be able to use the word, the gentleman yesterday from Microsoft says continuous validation. And continuous validation also assumes, though, that the validity has a metric, something that you can actually say, yeah, okay, that's a 0, that's a 1, that's a 0.2. How do you quantify the validation? Then becomes a key component of the discussion as well. Now, in the ideal world, I'm going to have a knob that's going to go, yeah, it's like a volume control. It's too loud. I'm looking for the Goldilocks sweet spot. And conceptually, that is where we are hoping to go over time. Now, when people say that these networks are ridiculously complex, that's very true because this is a tremendous oversimplification of a very simple network. And what you're seeing in here on the left is the way the network is configured. And then on the right, if we apply the analog network security trust concepts into it and the weighting factors, we actually get hard numbers every single time that a question is asked. Once the initial data set is populated, it has populated and constructed the first iteration of the algorithm. So the numbers do exist, and you can shift it again every single time because it's going to shift the bias of it based upon the internal questions, the questions that are being asked of the system. So responsible training. Part of the goal is I want to responsibly train my data so that when you ask it a question, it's going to give me the right answer. And again, this is only workable in the world of security. In one place that I've really seen it is your own self-referential behavioral network anomaly detection system. You want to make sure Bob isn't here and Sally's not doing that and who has access. And this is assuming you have detection and depth built into your network. The only way to have a data set that is neutral for you is to use your own data set and use no external data. Good part is you are going to approach neutrality and get really, really close very, very quickly. But the problem is that it's going to take a long time for it to train it. You can understand the model, but the data accumulation and the accuracy of it is going to take longer than using an external pre-programmed data set. Now, bias shows up in the simplest ways. Here's another one of those offensive things. this is going to change. This was, and you can go into various search engines and see some amazing stuff. This is all based upon queries. So based upon the number of queries that come in that ask those questions, those give it the prompt that are saying, oh, if all these other people are looking for this, you must be looking for something similar. And that is how the suggestions that are coming out of the AI system are brought to you based upon other people's, in this case, is obviously prejudices. Now, poisoning is something that we've been experiencing, well, fake news, the trolling, the social media, all that stuff. And fundamentally, the data sets are being poisoned by the bots because of the types of queries, because of the sheer number of people or bots or entities that are using certain terminology, which becomes self-reinforcing, creating positive feedback, which influence then the neutrality of the data set, which means that when you search for something, the amount of trust that you can have in the validity of that answer has gone down substantially. And this is what we're seeing out here. How do I know that the answer I'm getting has any relation to what I'm looking for? And this has been due to massive, massive poisoning. Admittedly, Facebook and all the guys they're all part of the problem, and they also need to be part of the solution. So bias can be introduced hostilely in many, many ways. And this is where Clarence Chow and I first really met, because he was talking on AI, and I'm sitting in the audience, says, yeah, but I know how to screw with that. I know how to screw with that. And that's began my AI education, because he was looking at it as pure theoreticals, and I was looking at it from a red team, blue team standpoint, and we came up with vastly different answers. So I'm not going to go through all of the statistical learnings, but this is a big area of study that is, it's mind-numbingly mathematical and statistics, and the data scientists admittedly are working on it, but the answers are not here today. One of the biggest areas that we have culturally today is obviously with some of the race issues here in the States, and AI isn't helping. Face recognition is one of the ones that is touted as being miraculous. And yeah, if you're a white guy or a white woman, yeah, that's true. But people of color anywhere around the world are having extreme identification problems, false identification problems, and you go for true negative, true positive, false negative, false positives, because of the way the data has been mistrained and the data sets were wrong in the first place. So this is not going to go away soon, because it is a massive, massive set of logistical problems to be able to compensate for the differences in human faces across 7.5 billion people. And how do you find neutrality? And I'm arguing that's not going to happen overnight. One of the other cases that false positives, that positive feedback triggered was in Texas. Not defending Texas at all, but Texas decided a number of years ago that they were going to try to do sentencing, and instead of using the potentially capricious bias of a judge or a small group of sentencing panel, that they would use AI, plug it in, and let the computer decide the sentence. And so they did that, and somebody from Southern Poverty Center or something like that said, wait a minute, all the people of color, boy, they're going away 5 times harsher and much worse than are happening to white people. And they went in and looked at the matrix and the neural network that was doing this, and they discovered that their original data to create their version of neutrality was based upon all of the sentencing that they had done and were trying to reject because they were inherently racially biased. So it was propagating further, and there are too many egregious examples of this going on. We're gonna. This one has a certain degree of humor to it, and it could be done over time. I doubt that millions of American or English-speaking tourists are going to want to really mess with it. But it's absolutely doable with enough questions. If you botted in enough translation questions and answers and gave it the misinformation, yeah, you could shift some of the answers in this. From an AI standpoint, by the way, this is language translation is one of the things I really like. I think it's great. Is it exact? No. Do you get giggles out of it from time to time? Oh yeah, but I've been really impressed with the fluidity of it now, and people's reactions that, yeah, okay, some error is acceptable. And that is key to whatever you're thinking with any AI application, whether it's in security or anything else, is you are going to have error. How much error can you tolerate? These are some of the models that Chow and others have been looking at on how to correct error bias over time, and building frameworks for this in order to be able to achieve the concept of explainable AI. So these are, don't worry about all the schematics, but people are working on these things. And the explainable AI is absolutely critical. And one of the questions I ask folks that are putting in a system such as this, I say, would you hire a C-suite executive, a CISO, CTO, anybody in a decision-making process whose credentials are great? Wow, what a resume. They talked well and they passed all the tests. And the only problem is they say, you give me a problem, I'll give you the answer, but I'm never going to tell you how I got at it. You just have to trust me. Would we do that in the human domain? No. So we are allowing ourselves to inch forward more and more by the adaptation of these technologies that still are unexplainable. And as Stephen was pointing out, runaway, we trust one, perhaps inaccurately. Then we trust another. Then we glue them together. What happens to the trust value between these systems when we don't even know how one of them works? And now we want to tie some together to be able to have additional deep answers? I argue absolutely no. So folks are working on the stuff. It's just not there yet. How much should we trust this stuff in security? If my doctor punches in, okay, Winn, here you got this, you got this, you got this, and here's what I think, and it goes off to whether it's Watson or whatever the smart cloud-based doctor is, and that one says, well, there's an 82% chance of this and a 7% chance of this, and you probably should lose some weight. Yeah, okay. Who's making the decision? Ultimately, the human should be making the decision, because we don't know how the AI is coming to its determinations. And ultimately, in my opinion, it ought to be an adjunct. It ought to be a suggestion. It ought to be listening to other experts and then making a final determination versus a universal, I'm just going to trust it. Now, when it comes to insecurity, do I want more alerts? I heard yesterday from Chris, it's overwhelming, the number of alerts. So how do we configure these systems for greater granularity and more accuracy in an alert system that you might use this technology? Well, how do you measure it? How do you measure it? How do you know? And this is something we don't know. And I question the true value of adding some of these technologies into these places. Is your current anomaly detection, whatever it is, whether it's code, human, doesn't matter, is it doing the job? Cool. But do you want to automate that entire process to something you cannot explain? So some takeaways, and then I'll be happy to answer questions, is really, these things are not God. They are not binary. They do not give you the answer. These are suggestions that are coming out of them based upon, at this point, faulty assumptions, faulty data, an inability to explain, algorithms that are misconfigured, which is just, it's the equivalent of sending out bad code and there being a 0 day in it. When Microsoft sent out its tweet bot what, 2-3 years ago, what, in 24 hours, it became a complete racist because of the poison ability. Things have gotten better, but the adversarial use of this technology is going to be part and parcel of cyber war future. It's the adversarial network, GANs, generative adversarial networks, using that to learn how to play Go. That's kind of cool. Learning how to attack every planet, every network on the planet at once automatically using these technologies. We're going to end up with GANs fighting each other. Not too happy with that. So there are some places that AI technologies are applicable in security. I know that a parent company, they use a lot of AI in order to help determine what kind of training is best for a particular user who may have a weakness in one area or another, or behavioral issue, or what, it doesn't matter, but in training. And those are suggestions. There's no life and death decisions that are going to cost your network or your company or lives. So be very careful about how much you actually trust these things, and go question the heck out of your vendor. More offensive stuff. I was just advocating, I love translations. Well, again, expect errors. It's gonna happen. When you're talking to your vendors about why you should be moving in this direction, it's really a lot up to you. What problem are you really trying to solve? How much money is it worth? And can you measure incrementally the difference? Is there an ROI? And is the potential for error in these systems such that it's just not worth it? And so there's a lot of technology that you need to look into, a lot of questions for vendors, some of which are just unanswerable. And those that try to give hardcore answers, caveat emptor. So that is the basis of my thinking on AI as it stands today. I would love to hear your questions either here or off on the side. We can visit on a channel, and I'm going to cease my sharing and hand it back.
Yeah, Winn, take a look at the Q&A window. I have a couple questions there.
Yeah, I got to get out of where I am here. If I stop sharing it,
yep.
I got. Where's the stop sharing screen?
You're not sharing.
Good. Q&A window. Check Q&A. Okay. From Abby.
Your mic's got a lot of static though right now. I don't know if that's something that.
Does it still have static now?
I hear static. Yeah.
You do. I mean, I can go over to another microphone. If it sucks, I'll go to another one.
If you have another one. I don't know what happened when the video or when the presentation stopped. It started to get really staticky.
Well. Really should be.
Like something came a little bit loose, or.
Yeah, that's why I was just plugging it back in.
Do you have one in the computer that's built in if you took the mic off?
Yeah. I got it. I gotta get to the right window to do this. Just move.
We have the other option is.
No, I'm the microphone over there.
Okay.
All right, is that better?
Oh, it's awesome. Yeah, we're doing great on time as well.
Oh, we are. I shut up in time?
Yeah, you sound great now.
All right, then all right, so is there any way to teach an ML different values? Like, what if a person on one side of the track is almost done making the cure to COVID-19, and only he knows the solution, and the other side of the track has 5 normal people? What if it's a pregnant woman and 2 full-grown men? All right, Abby, that is an ethical question. I'm not going to answer it. That is the problem. You've recognized the problem. Creating ethical dilemmas. There is a Facebook group, and I may have the name wrong, but it's something like the trolley problem or trolleyological conundrum, or something like that. But it's a fun Facebook group that shares drawings that are iterations of that. Spot on question. I'm not answering it. And teaching values. If you teach values, that you're teaching your value or my value or John's value. Or what about Hindu values? Or wait a minute, the Hindu values, what about the different Hindu sects? Do they have the same value? And how are values decided? And now, is the same value going to be in Saudi Arabia? It's the right question. You can design your own for you, but the universal design of these things, I think Stephen got into it as well with global existential realism, that this is a very similar type of answer. Autocratically, sure, I'll make the decision. I'm a good guy. Now you got to live with it. Do we want to do that, or do we go with Stephen's hope? And it's the same question in a different framework. And I know that doesn't answer shit, because there are no hard answers. I want you to think about this. And Abby, give me an answer. All right, next question. If you give AI ML the ability to learn from all the data you input, what happens when the AI ML decides detrimental solutions to the issue? If you input more data to counter this, then doesn't that just give it more of a reason to decide that removing the contradicting data, oh boy, that problem is, I didn't answer it. All right, that one just disappeared from my window because of others popping up. Yeah, no, you're talking about shifting bias, and it's that ideal knob. So algorithms are getting better. Self-correcting algorithms, OODA loop-based algorithms where you've got more feedback mechanisms in them, introducing secondary analysis in the feedback mechanisms and affect the weighting of that data that is coming back in. Is it self-reinforcing? Is it shifting the bias in a positive or negative way? And then how do you monitor that? And this is the problem. Again, I hate to say there are no answers, but that's why there are several slides up there. It's like, these guys are working on this stuff. Maybe less from an ethical standpoint and more from a technically accurate standpoint, but I view them very, very similarly. So again, sorry, I don't have an answer to that. How do you reduce bias? No clue. No clue. I think we're trying to solve some really, really big problems. And I think the subset problems are going to give us some more control, some more ability to understand this. And I'm hoping the AI researchers are really doing this. Controlling bias. I wish I had a hard answer. I showed you some of the approaches that they're taking, but which ones are going to work? And how do we measure it? How do we decide? If you're happy with the answer and I'm not happy, is the AI at fault? Again, this comes back to consensus. Bias is consensus. Next, is there anything like an MIT moral machine for genetic? I barely know what that question means. So I'm going to defer that to genetic hacking experts somewhere else. I don't know. Again, thank you. There's no more questions, and I'll be hanging around watching. And
yeah, thanks.
Everybody be safe. Stay well.
That was a great presentation, Winn. I know you had a lot of participants and participation. So Winn knows how to use Discord, and Winn will be in and out of Discord, and so he'll be around the rest of the conference, I think, and very willing to take your questions and chat with you. So
yeah, or ping me on Facebook. I mean, we have multiple channels, so yeah. I'm around. I was going to watch sports maybe today a little bit, but there's talks I want to hear, so I have to now have more monitors up on my desk.
All right. Have a great day. Thanks, Winn.
Thank you.